Welcome to Let's Solve. I'm Greg Warren, and today I'm going to talk you through how to solve a nonogram puzzle. On screen, we have a 15 by 15 nonogram. The aim is to shade in certain cells of the grid to reveal a hidden image. The numbers outside the grid tell you how many shaded cells are in that row or column. Let's get started. This puzzle has a really nice lead-in with the two bottom rows. Each has 15 shaded cells, and this is a 15 by 15 grid, so we know every cell in each row can be shaded. You can cross off the two 15s on the left to show that these rows are complete. Now, look at the hints in the columns. We know that the row of circled numbers must form units with the two bottom rows we have already filled in. So go ahead and shade in any missing cells for the bottom numbers of all the columns. At this stage, we have now filled in all possible shaded cells for several rows and columns. Let's go ahead and put a cross in each cell we know must be blank. Take a look at these circled numbers. As there is only one cell remaining in two of these rows, it becomes clear that there is only one place this block of 3 cells can go. Next, let's look at this lone 3. We know this must form a group with the one shaded cell already found in this row. With the eliminated cells either side, we know that the two shaded cells must be in columns 5 and 7. If we go down to the next row, we know that the shaded cells furthest left in this row must consist of 3 cells. This leaves only one position that the 3 cells can go, so we can fill those in too. Moving back up to the columns, we can complete these 2 columns by shading the cells immediately above these blocks of 2 to make up the required 3 in each. We can also mark the rest of the blank cells in these columns to look like this. Although we cannot fully solve this column yet, we can count 4 cells from the top down and 4 cells up from the first available cell, and mark the areas where these 2 counts cross. Looking at this row, we know that the cell to the right of our shaded cell must also be shaded to form a group of 2. We can now also mark the cell immediately to the right of the 2 shaded squares as a blank. Looking at this column, we can solve the first 3 numbers now, as they can only fit in one possible combination. We can cross those numbers off from that column and mark the blank for the spaces in between. Remember our counting technique for the previous 4 in a column? Let's apply that again in these rows to solve and eliminate even more cells. We know the cells with dots can be shaded in order to fit in the group of 4, and we can then mark all other blanks in these rows. There is only one possible location for the group of 4 cells in column 14, so we can shade those in. You should now have something like this. Although we do not know where to place the missing shaded cells yet, it does allow us to eliminate cells on the left-hand side of the grid. We can now see there is only one possible solution for this pair of 2s. That's another column complete. Let's go back to this row. We have found the 2 ones furthest to the right already, but now we can also complete the missing 2. This also solves row 1 for us, as we know the topmost cell must be blank, since the group of 4 in column 9 cannot include the top cell. The grid should now look like this. We can see there is only one possible location for the 2 and the first 1. Let's fill these in now, which completes rows 3, 4, and 6. We can complete the group of 4 in column 9, so the rest of row 2 are blanks. This leaves only one possible location for the 1s in columns 2 and 3. Finally, let's solve these last sections. We have already found the first 2 1s in row 9, so we have to try and fit the remaining 3 single shaded cells into 4 spaces. Now we are left with just a single cell that we know must be shaded to solve row 8 and column 14. And that is how you solve a puzzler nonogram. For more information on nonograms, where to buy them, and our other puzzles, visit www.puzzler.com.